We are going to talk about, sorry? We are going to talk about the curl of a vector field. We have to reduce the volume of my as I said, the curl is like this. Okay. It's a vector, right? For the Cartesian coordinates, that was equal. We can use a matrix form I, J, K are the unit vectors along x, y, z direction. Maybe let's say the x component of A is magnitude of x component of A is AX, magnitude of the component of A along B, Y is Y, and similarly AZ. So the answer is I Z. So this one and this one. The second part is minus. This is Y. Y. Z. Z. Y. So J. So these are the three components. And similarly, the cylindrical coordinates it is one upon R is a component of E in Z direction minus R plus plus 1 upon R R minus Z component. So this is for the coordinate system, and similarly you can find it for the spherical coordinate system. So you can do it later as a homework, and there are a lot of mathematical tools that is support to this. Is there any problem, students?
Sir, low part we can't see.
Yes, then so real time you have to respond. So I didn't know then because it is a class and If there is a problem, you can ask it. Now, can you see the lower part?
Yes, sir. Thank you, sir.
If you have any problem, you can ask. You can interrupt me. Right. I think I have given you an example. Let's do one more. One more sample. What is A? A is let's consider the Cartesian coordinate system, because for the cylindrical and spherical coordinate system, it is little bit restrictive, but don't worry. There are a lot of mathematical tools, softwares to solve that kind of thing. But in order to understand how to operate it, let's work with the Cartesian coordinate system. X, Y, Z, I is the unit vector along x direction, plus 2x squared z j plus 3 x y plus z. Okay. So first, I will ask you to find the divergence of A. Divergence of A Is this a scalar or vector?
Scalar.
Yes, very good. Thank you so much for the response. It's a scalar. Then what do you think about this? So this is a scalar field. And the temperature distribution among the given space is also can be considered as a scalar field. So what is this?
Vector.
Yeah, it's a vector. What
Yes.
is the name for this? This is a vector. This is a scalar.
Divergence of above one.
Divergence or gradient. It is called a gradient. So gradient of divergence of A. This is called the gradient of the divergence of A. So what is this?
Curl of A.
Very good. Curl of A. And find the One more part. What is this? Huh?
Curl of A.
Curl of A. Right. Please find the answer of this. Uh, 1, 2, 3, 4. I will give you 10 minutes. Have you done it? Students?
Yes, sir.
Okay, let's see what is the answer. Right. The first part, the divergence of A. What is the divergence value? What is, can you tell me?
So 3xy plus y z.
3xy plus y
Y
is,
z.
okay. Wait. I will show you how to use a mathematical tool for this. Have you ever used the Mathematica software?
No, sir.
Hmm?
No, sir.
Okay. You can visit to the wolfram.com site. I will copy and paste it into a chat box. If you visit into the wolfram.com site, you can do some online calculations there. But I have obtained the copy of that software then without the internet connection. I can work with that. This is the wolfram.com site. So let's see how to take the divergence of a vector. I will share the screen. So we will receive this type of software. We can use it for the documentation, and I will select a new document. So again, I have to share it. Yes, this is the blank document of Word form. Now we need the divergence of a vector. So we can type it like this. The syntax is what's going on? Divergence div square bracket. What is the x component of our vector? xy
XY z.
xyz. Yes, and the xy,
2.
yeah, x
2.
component and y component and z component can be written in this form for the Mathematica software. Yes, this is the x component. Can you see it? And
Sir, we can't see that.
shall I magnify it?
So we can see only the window.
Only the window now.
Same, sir.
Same. So I think I am working different. Yes, I have used another one. I will close this. I don't want. Can you see it now? No.
Not yet, sir.
How about now?
Okay, now okay, sir.
Okay, I will magnify this. So XYZ components can be written like this. This is the X component. This is Y component. This is Z component. And so after that, we have to mention the coordinate system. It is Cartesian coordinate system, no? So simply we can write it like this: x, comma y, comma z, y. Yes. And cos it. Is this the answer that you get?
Yes, sir.
Yes. Right. Similarly, the next part is gradient of divergence of A. What is the answer?
So 3yi plus 3x plus zj plus yk.
3y
3yi
I
plus 3x plus z within bracket j
j.
plus yk.
Right. Okay. Let's see. And with this mathematical tool, we can find the divergence, and so this is the gradient. The gradient value is this 3xy z. So now we have to find the, so this is divergence. It's a scalar, and now we have to find the gradient of that scalar. So let's see. You said 3y, 3x plus z plus y.
Yes, sir. Correct.
Correct. Okay. And the next part is the curl of A. What is the curl of A?
So I component 15x plus 3x z minus 2x square
Uh,
minus j
uh,
within bracket 15y plus 3y z minus xy plus k component 3x z.
3x is it? Okay. Let's see the answer with Mathematica. These are the xyz components of the vector A. Is this answer correct?
Correct, sir.
Correct. Okay. So we can use this software to do some calculations, the Mathematica, MATLAB, Maple, and for the simulation parts, ANSYS, COMSOL softwares can be used. But to understand the operations of algebraic operations uh, and the waveform generations, we can use Mathematica software very easily. Uh, in order to plot a curve, if you need to solve an equation, simply you can type it like this, x plus 5 equal to 0, and what do we need to find is x. Very simple. So they were given the answer x as -5. So if it is a very descriptive question, equation, I will make it complicated. So we can use palettes, basic math inputs to get square and square root and integration. So this is a square root, and I will the let's see the answer for this. There is no solution, and how about 2? Maybe we can type it like this, find root. And we can so you can find the answer for this problem make it simple. So x squared. And if it is 3, you will be given the answers like this.
Excuse me, sir.
Yes.
Sir, can we see the steps in calculations? can we see the steps in this?
Steps means just you have to type it, and after that, at the end, you have to press the shift button. While pressing shift button, you have to press enter. Then easily you will be given the answer.
Okay, sir.
Are you in the Wolfram site now?
Yes, sir.
Okay, then please play with that. And if you need to plot a graph, let's try to plot a sine graph. Sine x, where x going from 0 to 6 pi. 6 pi. Let's see. Yeah. And after that, if you need, you can manipulate it. I mean, animate it by changing the variables. Let's see how to do it. I also don't remember. I will find out how to do it. Because this help document is very useful. Yes. Let's see this. The help button. Sin ax plus b. So we can use a manipulate option to find. So a is varying from 1 to 4. B is varying from 0 to 10. Let's see. Still running. Yeah. And this is the function, and I will increase the range of x up to 6 pi. 6 pi. So this is the function. Then if I increase a, the width of the number of cycles decrease, and if I increase b, the phase angle is changing. Yes, and also I can run it, and so that is a useful thing to understand where the wave is propagating. Okay, is that clear? Is that clear, students?
Yes, sir, clear.
Okay, so you can find now we found the divergence, the curl of A, and again you can find curl of A. Please do it. And we found curl of A here. Where is that? Yep. This is the answer. You can copy it and type curl comma x comma y comma z. What is curl of A?
So 3yi minus within bracket 3z minus 3x j
Yeah.
plus yk.
Yes, and we have obtained that answer using mathematical. So right now we can what do you think about the answer of this? Is according to the distributive rule. Addition of these two. And these are the properties of the curl. first we can get the divergence of B. No needed out here. Minus B divergence of E. Plus B A minus del operator is multiplied, get the dot product of B and it's a scalar, then multiplied it with the vector A. So this is the second rule of curl. Keep this in your mind. There are two rules. And for the previous example, what can you say? The divergence of curl of A. What is this? Can you see it? Can you see this?
Yes, sir.
What is that?
So,
What is the answer?
so we got gradient of divergence.
No. No, I mean, if you do it, what will be the answer? Curl, this is a curl,
Grade
this is
vector.
the divergence. Divergence of curl of A. What would be the answer? I think in the last lecture we discussed.
Scalar.
No, it should be 0. It should be 0. Why? Why is that?
They are perpendicular to each other.
Yes, the curl is normal to the surface of the vector field, and if you get the divergence, that will be cancelled because the dot product of two vector having perpendicular with each other is 0. Right? So now let's see the properties of a curl. First one is the curl of a vector is a vector. First property is a vector. What is the second property? Any curl should be a vector.
It is perpendicular to both.
Yes, it is perpendicular. And what is the curl of a scalar? Scalar. Huh? There is no meaning. No need to mention it because always, if you are taking a curl, there should be a vector. Second, curl should follow the right hand rule. And if there is a vector field here, E, in this direction, the curl of A, something like this. It's called the right hand rule. Thumb direction is given the curl, and curly fingers given the vector. Okay.
Okay, sir.
And I think you are familiar with this.
Yes, sir.
Means right hand rule. The current direction. If there is a current in this direction, there is a magnetic field. Along this, and the direction of the magnetic field, whether it is rotating in the clockwise, counterclockwise direction or clockwise direction, that depends on the direction of current, and the rotation direction of the magnetic field is given by the right hand rule. The curly fingers given the direction of the magnetic field. Okay.
Okay, sir.
What would be the third? Yes, the third, as we discussed, divergence of the curl of a vector field here is it we get right the divergence of curl used property the fourth property, the curl of the gradient of a scale is always zero. This is also always zero. So the curl of the divergence of a vector scalar field sorry, no, not the divergence, the gradient vector field is always zero. How to write it? Of the curl of a divergence of a vector field, then let's take the potential is always zero. Because this is a vector. Divergence of a scalar is a vector. But if you get a curl, that is always zero. Can we try it with an example?
Okay, sir.
Okay. I will use mathematical tool. I think we got a scalar value because the last time we got the divergence. The divergence is a scalar, no? So I think I did not share the screen. Yes, I think you can see it, no? So I will consider this value as a scalar field, 3xy plus yz. Then I will get the gradient of that. So this is the gradient of that value 3y3x, and now I will get the curl of that. Curl What is the answer?
Zero.
Zero. And for any type of value, then I will change this as x, y is y to the power 5, 55, and x to the power y plus x squared. I can make it complicated. X to the power 4, and the answer is this, and we can get that is it. So as I said, curl of a gradient of a vector is always 0. Yeah. And the fifth one. So, divergence of E is not equal to the this is the fifth rule. These two are not equal. So this is the divergence of A. This is the product of A with the del operator. So those are the examples. The last time I talked about the Laplacian operation. So the Laplacian is like this. Red square is called the Laplacian operator. Then for the Cartesian coordinate, this is the Laplacian operator is actually the scalar product of del operator. Okay. Will be okay. Hello.
Okay, sir.
Right. And let's see the Laplacian operator of this operator can be used for vector and scalar both. Let's consider the vector scalar field. I think you remember the value expression for the divergence of A. What is that expression? Can you tell me? I will consider it as a B.
So 3xy plus yz.
A
X y plus yz.
Y Z. And let's take the this is scalar Laplacian of a scale. Then monitor vector. Three xy plus yz plus double squared upon double y squared 3xy plus yz plus double squared 3xy plus yz. What would be the answer of this? What is the answer here? First operator 3x then 3y, it is 0. Yeah. Am I correct?
Yes, sir.
Because since there are second derivative, definitely this answer shall be 0. Then I will consider some more power. Then it is non-zero value. Then first 3 6 6 times 3 is 18. 18 xy. Am I correct?
Correct, sir.
Okay. The second what is that? The second terms definitely this is 0 because since there are second derivative here should be 2 is it? Am I correct?
Yes, sir.
Now, yes, the order of Z is 1, then definitely this should be 0. So this is the scalar Laplacian. and you should know how to use it for the cylindrical and spherical coordinates. But we are engineering people, then we can use the mathematical tools and the softwares to solve that, because we need to work with more applications. Yes. And the vector Laplacian, if you remember, please tell me what is the A value that we get. Expression of A.
So x, y, z, I.
Sorry?
X, y, z, I plus
X, Y, Z, I.
2x squared z,
2x squared
z, j
J
plus 3xy within bracket 5 plus z
3xy
within bracket
within bracket
5 plus, yes, 5 plus z. Okay.
So the Laplacian of a vector field is, that is a vector. But the Laplacian of a scalar is also a scalar. Definitely this part should be seen. I. How did I come to know? Came to know? The power of x, y, z is 1, but we have to give the second derivative of x, y, z. Then definitely it should be 0. But here, and 2 times 2, x part will vanish, but the 4 comes because of that. 4 z. 4 z. G. Here also x, y, z parts, the power of x, y, z parts are 1. Is that correct? Okay.
Yes, sir.
Double check. So this is the answer, and this is a vector. Right. So when we consider the scalar Laplacian, we have to deal with the electric potential. Laplacian is linked with the electric potential, and the vector Laplacian deals with the wave form. I think you know the wave equation. Do you remember?
No, sir.
X square phi equal 1 upon c square as I remember, this is w upon w t square psi. This is a wave equation. This is a vector. So if you get the Laplacian of a vector that deals with a wave function, maybe later we will derive it with the Maxwell's equations. So now we can classify the types of vector fields. Classification of vector fields. First thing is the irrotational vector field. Irrotational vector field. That is, we take the curl of a vector field is 0. If a curl of a vector field is 0, that is called irrotational vector field. Example for the irrotational vector field is like this. It emits isotropical. This is called irrotational, IRRO field. So the one type is that, and the rotational type is actually rotational vector field type is like this. It's rotating. But for the irrotational vector field, the curl of a vector field should be 0. Then, if you get this type of answer, keep in your mind that vector field is irrotational. And if you think that vector field is irrotational, you have to get this consequence.
Excuse me, sir.
Yes, please.
So now it is 11:21, sir. We have another lecture.
Okay, give me 2 minutes. Okay.
Okay.
Okay. So for the irrotational vector field, that should be straight line. Lines. Second, if the curl of A equals 0, then the integration, line integration, along the closed path is to be 0. So for the solenoidal vector field, maybe next time we can discuss the solenoidal vector field. Shall I wind up?
Yes, sir.
Okay, then let's meet on next Tuesday. I will upload this to the Google Classroom. Have a good day.
Thank you, sir.
Okay.
Thank you, sir.
Welcome.
Thank you, sir.
You're welcome.